Okay, Zishan, thank you for joining. Zishan, are you there? Can you hear me, Zishan?
Yes, sir, I can hear you.
ठीक है. So thank you very much for joining. ये we'll try to finish in 1 hour 10 15 minutes. Huh?
Okay.
ठीक है. Looks like you are the only one here. So feel free to enjoy this luxury.
Okay, sure.
So once again, this is a pre-recorded lecture for the lecture which is scheduled for Saturday, October 31st, and we are pre-recording this. Zishan is here with us, and is the only one in the audience. But it is good to have at least someone in the audience rather than talking to an empty virtual room. Um, so we pre-recorded one lecture earlier today, in which we finished off with the discrete random variable. We'll come back to the discrete random variables later on when we talk about the correlations between the random variables and estimations. But we are going to switch gear a little bit and move on to what we call the continuous random variables. Continuous random variables. Continuous random variables. So what are continuous random variables? Continuous random variables are one which take random variables which taking a continuum of values. इसका क्या मतलब है? Continuum of values, which means के discrete random variable से अगर contrast करें, so discrete random variable was taking values which were discrete. It will take value 1, 1.3, 1.7, 1.9, 2.7, 2.6, and so on and so forth. Some discrete number of values. So continuous random variable will take a value. It can take any possible value, value between 1 and 3, for example. So a continuum of values will be taken by the continuous random variables. These random variables will still be um, conforming to the definition of the random variable, which is mapping of the sample space outcomes onto the real line. Sample space की जो outcomes हैं उनको real line के ऊपर map करना, which means कि the value that the continuous random variable will take will also still be a real value. Okay. So while we computed the probability mass function for the discrete random variable, okay, what is the probability a discrete random variable can take x is equal to 3.7, उसकी probability निकालते थे. X takes a value 8.2, उसकी probability निकालते थे. Continuous random variable के case में चूंकि the number of values it is taking is infinite, it would not be possible for us to list all of those values. Okay. Some examples of continuous random variable, हमें कुछ तरीका ढूंढना पड़ेगा continuous random variable को define करने का. So examples पहले इसकी बता देते हैं कि lifetime of a light bulb. Lifetime of a light bulb. This is a continuous random variable. It can take any value. Convince yourself that it will not take discrete number of values. Also, a measured temperature at a location. Okay? Or it could be airflow speed. Airflow speed. ये कुछ भी हो सकता है. ठीक है. Formal definition क्या है? Formal definition of a continuous random variable is that कि a random variable x is continuous if if there exists a non-negative function, if there exists a non-negative function with the following property. If there exists a non-negative function f defined for all real x, in minus infinity, minus infinity to plus infinity, for all real x के लिए define कर सकते हैं fx, okay, uh, with the property, with the following property, with the property that for any subset b of real numbers, यानी आपके पास एक रियल लाइन है और उसका एक सबसेट आपने b ले लिया, so this is, let's say, your real line. Take this subset b, and for any b you can define a function such that the probability x is in b, x is a random variable which takes a value which falls within b, is given by the integral over b fx dx. अगर हम कोई ऐसा फंक्शन fx फाइंड कर सकते हैं, which for any b can satisfy this equation, that the probability x belonging to b, the random variable x taking the value b, then we say that x is a random variable. Then we say that x is a random variable with, ये अब ये जो fx है ये स्पेशल, इसको एक स्टेटस मिला है, with fx as its probability. वहां पे मैस फंक्शन होता था डिस्क्रीट के केस में, यहाँ पे डेंसिटी फंक्शन होगा, probability density function of the random variable x, okay. So the way that we write it is that there is a random variable x which is distributed according to the probability density function f subscript capital X evaluated at small x. Once again, capital X is the random variable and small x is a fixed value, and that fixed value means a constant value. Instead of fixed value, I should call it a constant value. Okay. So how do we differentiate between the continuous random variable and the discrete random variable? इसको कैसे distinguish करेंगे? Okay. इसको distinguish करने के लिए, let me just draw this picture here. And use a different color. Okay. So let's say you have a probability mass function, discrete random variable PMF, which is written as Px of x. This is the probability mass function. Let's say this is the probability mass function. Okay. Now I consider an interval. B here. ये आपका एक इंटरवल b हम कंसीडर कर लेते हैं, इंटरवल b को कंसीडर कर लेते हैं. Along the horizontal axis we have small x, okay? And then this random variable can be taking value 3, 5, 6, 7, 9 and 13. Okay? Some random variable with certain probabilities p1, p2, p3, p4, p5 and p6. Okay? If I ask you the question, what is the probability that your random variable x belongs to b? This is an event. Belongs to b means it is taking a value. X is in 6, 7 or 9. It's taking a value 6, 7 or 9. So this would simply be equal to p3, this guy, plus p4, value 7, plus p5, taking a value 6, taking a value 7, taking a value 9. This would be the probability that this discrete random variable has taken this value. This is the probability that the discrete random variable belongs to this interval B, belongs to this interval B. So I'm going to do the same exercise for a continuous random variable. For a continuous random variable, instead of probability mass function, we have what we call probability density function, okay, which is f capital X small x. Okay. Instead of pxx, we have fxx. Okay, and the probability density function is going to look like this. It's going to look like this. Okay. And we can define an interval b here. Then interval which we define will be this. So this is your interval b. This is your interval b. Okay. And in the case of continuous random variable, the probability that your random variable belongs to B, takes a value within B, is equal to, instead of summation, I don't sum all of these values. I can't sum all these values. Plus, this is not a probability mass function either. This is a probability density function. So according to the definition, that x belonging to B is summation over all B, or integral over all B, fxx dx. So this would be equal to integral over the interval B, where B is an interval which could be from 3.2 to 7.9 or anything, any interval that you choose. This would be fxx into dx. Okay, so this is a summation. This is a summation in the discrete sense, and this is a summation in the continuous sense. Summation in the continuous sense. Okay? So just like PMF, the PDF integrates to 1. Okay? Probability mass function sums to 1. Oops. Sums to 1, and the PDF integrates to 1. That is integral from minus infinity to plus infinity. All the area here, minus infinity to plus infinity, fxx dx. This will be equal to 1. Now, like we saw in the case of discrete random variable, that the probability that the random variable takes a value 3 is given by this probability P1. The random variable takes a value 3 is given by the probability P1. What about the continuous random variable x taking a specific value here? The random variable x taking a specific value here, is this equal to this height? No, this is not equal to this height. We'll come back to this. In a second. Okay. Now, let me provide one example here. I can take this interval B to be equal to a closed interval A to B, interval small a to small b. What that means is, this capital B, the interval is small a to small b. Small a से small b तक. So basically, when this integral is written here, that means it's over the interval capital B. That really means the probability that x is in the interval capital B is equal to the integral going from small a to small b, the definite integral fxx dx. Okay, this is equal to the probability that x is between a and b. The probability that x is between a and b. Okay. So just wanted to make sure, Zishan and Umar, you guys are able to hear me?
Yes.
Great, great. Thank you. And Umar, thank you very much as well for joining. Um, जिशान साहब की लग्जरी थोड़ी खत्म हो गई है. पहले जिशान साहब अकेले थे. The whole virtual room belonged to him, but now share करना पड़ेगा. That's okay. Okay. So so now what is the probability? What is the probability x is equal to small a? X takes a specific value. ये यहाँ पे कोई specific value ले ले. C कह देते हैं इसको. X takes a value small c. What is this probability? What is this probability? Is this equal to the height here? No, it is not equal to the height here. Huh? For x, a continuous random variable. If x is a continuous random variable, then we cannot have the probability x is equal to c defined by the height here. Why? Because अगर ये फिर ऐसी बात है तो ये तो इनफाइनाइट हमारे पास वैल्यूज ऐड हो जाएंगी और उसका आंसर इनफाइनाइट आएगा. हमने तो इंटीग्रल जो है वो 1 पे लेकर आना था भाई. नहीं, ऐसा नहीं होगा. So let's find probability x is equal to c. So in this above expression, okay, let's put a is equal to b is equal to c. Okay. So that would be the probability that x is equal to c will be equal to integral c to c fx x dx, which is 0. This is 0. This is a probability that x takes a value c. So a continuous random variable taking any specific value, is always 0. The probability of that event is always 0. Continuous random variable taking a specific value, the probability of that event is always 0. लेकिन ये जो zeros है ना, ये zeros infinite zeros हैं. If you add up these infinite zeros, somehow magically this will turn out to be equal to 1, because this is 0 very close to 0. Okay. So we also have the probability that x is less than a to be equal to probability x less than equal to a. Why? Because the probability of x taking a value equal to a is 0. तो इसका क्या मतलब है? इसका ये मतलब है कि if you recognize this expression, this is the CDF. हमने discrete के केस में define किया था. Continuous के केस में भी the definition of the CDF remains the same. Okay? So the definition of CDF is the same, and that is probability x less than equal to a, written as fx evaluated at a. So now the CDF for a continuous random variable will have no jumps. डिस्क्रीट के केस में हमने देखा था कि CDF ऐसा होता था, ये CDF होता था स्टेयर केस टाइप का. यहाँ पे 0 होगा और यहाँ पे 1 होगा. CDF of discrete. Okay. For the case of continuous random variable, the CDF of a continuous random variable will be something like this. Okay. 1 होगा, infinity पे minus infinity पे 0 होगा, and this would be the CDF of a continuous random variable. This will be the CDF of a continuous random variable. Okay. कुछ examples करते हैं, clarity आएगी उससे. सबसे पहले example. CDF की एग्जांपल ले लेते हैं, CDF की एग्जांपल. So fxa is equal to the probability x is less than equal to a. This would be equal to integral minus infinity to a fx dx. So what is this? What is this? So let me just draw that. So this is your fxx, and this is x, and let's say this is a. This is a. Then fxa, capital F, small x, capital X, a, which is the CDF of a, is the probability x takes a value less than equal to a, which means it's this area here. It's this area here. ये यहाँ पे ये वाला एरिया. So ये वाला एरिया जो है, ये वाला जो एरिया है इसके नीचे, so this area is the CDF, and CDF is the probability x takes a value less than equal to a. And if you integrate it, जैसे जैसे आप देखें a को हम लेफ्ट में मूव करते जाएंगे, a को हम लेफ्ट में मूव करते जाएंगे, तो हमारा एरिया जो है वो कम होता जाएगा. a को राइट पे मूव करते जाएंगे, एरिया हमारा ज्यादा होता जाएगा. So this is the PDF probability density function of x, and this is the CDF of x, which will be minus infinity पे ये जीरो होगा. जब a को मैं माइनस इन्फिनिटी पे ले जाता हूँ तो ये एरिया जो है रेड कलर में वो जीरो हो जाएगा, and then it will slowly increase until when I take a to plus infinity, then this area will increase and go to plus infinity, plus 1. So this would be the CDF of x. जैसे जैसे आपका a मूव होता जाएगा वैसे वैसे जो है वो ये एरिया चेंज होता जाएगा. Let's do another example. एक और एग्जांपल करते हैं. So let's say you have a random variable x with probability density function given by the following. Okay? This is given by c, where c is some constant, 4 times x minus 2x square. Okay? When x is between 0 and 2, and it is 0 otherwise. Okay? You can plot this. Okay? 0 और 2 के बीच में ये कोई आपकी कोई शेप आ रही है, तो सबसे पहले what is c? What is c? Now, in order to find c, we know that the density function from minus infinity to infinity must add up to 1. We know that integral from minus infinity to plus infinity fxx dx should be equal to 1. What that means is कि fxx जो है आपके पास वो बाकी तो सब जीरो है, बस 0 से 2 के बीच में, between 0 and 2, this is c into 4x minus 2x square dx. This should be equal to 1. This should be equal to 1. Okay. Now, if I solve this, we will get c to be equal to 3/8. इसको सॉल्व करेंगे, इंटीग्रल को सॉल्व करेंगे, c आपके पास 3/8 निकल आएगा. इसी के बारे में, इसी रैंडम वेरिएबल के बारे में, what is the probability x is greater than 1? What is the probability x is greater than 1? So see, you have the random variable which is taking these values between 0 and 2. What is the probability x is greater than 1? X is greater than 1. So in order to find this probability, you can just integrate from 1 to 2, because this is greater than 1 to 2, c 4x minus 2x square dx, which turns out to be 0.5. ये आपके पास आ जाएगा. Now, very important to note कि ये हमने जो इंटीग्रेट करना है ये 2 तक ही करना है, इन्फिनिटी तक इंटीग्रेट नहीं करना, because the function itself is equal to this only between 0 and 2, and otherwise it is 0. So that means the limits of the integration have to be defined very, very carefully. Okay. Now, let me just talk about PDF and probability. How is PDF related to probability? अभी हमने देखा तो है कि PDF को इंटीग्रेट करें तो आपके पास probability निकल आती है, ठीक है? But let us talk about that. What is the probability What is the probability that x belongs to an interval? X belongs to an interval small x and small x plus delta. Let me just draw that in a picture. Draw that in a picture. And let's say this is your PDF fx, and I'm going to change the independent variable to t here. T here, it does not matter क्या variable है, इससे फर्क ही नहीं पड़ता कि क्या वेरिएबल है. ये t की जगह हम z x y कुछ भी लिख सकते हैं. Capital X should not change. What this is telling me is this is the PDF of this x. X is the random variable. So this is the PDF of x evaluated at t. Evaluated at t, and t is the random variable here. T is the parameter here. T is the constant here. Okay? Along the horizontal axis. T कोई भी value ले सकता है यहाँ पे. But t is not the random variable. X is the random variable. T is a dummy variable. उसकी जगह पे x भी हो सकता था, y भी हो सकता था, t भी हो सकता था. ठीक है. So now I'm interested in finding the probability. I'm interested in finding the probability that your variable, random variable takes a value between x and x plus delta. वो ये जो छोटा सा इंटरवल है, इस इंटरवल के बीच में ये वैल्यू लेता है. And size of this interval is delta. Is very small. Okay. So I am interested in finding the probability that x falls in this interval. X falls in this interval. And from the earlier discussion, this would be this area under the curve. This area under the curve, because this is the PDF. This is the PDF. So ये area under the curve होगा. And this area under the curve is going to be from x to x plus delta fx x t dt. So realize that कि जब भी हम इंटीग्रेशन कर रहे होते हैं तो ये जो वेरिएबल ऑफ इंटीग्रेशन होता है, ये t या ये यहाँ पे t इस्तेमाल किया गया, इससे कोई फर्क नहीं पड़ता. इससे कोई भी फर्क नहीं पड़ता आपके आंसर के ऊपर, एज लॉन्ग एज द इंटीग्रल इज डेफिनेट इंटीग्रल. ठीक है. क्योंकि t की जगह हम q भी इस्तेमाल करते, p भी इस्तेमाल करते, y भी इस्तेमाल करते, x भी इस्तेमाल करते, w z कुछ भी इस्तेमाल करते, हमने इवेंचुअली जो है वो डेफिनेट इंटीग्रल के अंदर हमने ये वैल्यूज x प्लस डेल्टा और x को पुट करना ही है. ठीक है. So this will turn out to be approximately now think of it कि ये जो dt है, t is a variable of integration here, fx of t is also a variable, but if the interval is small, in the small interval fxt is almost constant. क्यों? क्योंकि ये देखें, ये यहाँ पे एक वैल्यू ले रहा है, ये कांस्टेंट वैल्यू ले रहा है, और वो वैल्यू कितनी है? अप्रोक्सीमेटली f capital X of small x. So ये जो है इसको हम लिख सकते हैं कि this guy is approximately equal to fx of small x into integral x to x plus delta dt. अच्छा, ऐसा हमने क्यों किया? ऐसा हमने इसलिए किया कि हमने कहा कि यार ये fx of t था जो t के साथ वेरी करता था, वो एक कांस्टेंट वैल्यू ले रहा है, जो कांस्टेंट वैल्यू हमें यहाँ पे ये नजर आ रही है, और उस कांस्टेंट वैल्यू को हम इंटीग्रल से बाहर खींच लेते हैं because it is constant with respect to t, because t is the variable of integration. So this would be equal to fx of x, and integral of dt is really t going from x to x plus delta, okay, which is equal to fx of x into x plus delta minus x, which is equal to fxx times delta. This is the probability that your random variable x falls in this small region. Yeah. Things to be noted here: fxx can be greater than 1, can be greater than 1. Kyun can be greater than 1? Because this is a probability density function. This is not a probability mass function. This is the probability density function. This is the mass per unit length, mass per unit length. So this is the probability density function, probability density function. We all know that if you have a function like this, ठीक है, जिसके नीचे ये एरिया अंडर द कर्व जो है वो 1 हो जाता है, कोई रिस्ट्रिक्शन नहीं है इसकी हाइट कितनी है, क्योंकि इसकी हाइट बहुत ज्यादा हो सकती है, हाइट यहाँ पे 7 हो सकती है, as long as this area is very small, this area is very small. So so area under the curve जो है वो हमारे पास 1 नहीं होना चाहिए, ठीक है. So integral f(x)(x) must be equal to 1 minus infinity to plus infinity. So इसमें f(x)(x) मोमेंटरीली जो है वो 1 से बड़ा भी हो सकता है, 1000 तक भी जा सकता है, कहीं पे भी चला जाए, ठीक है. but the integration under the curve of f(x)(x), the probability density function will always be 1. So here you have a question?
यस सर. सर मैंने ये पूछना था कि आपने लेट्स इंफिनिटी लिमिट्स इंफिनिटी तक जा रही हैं
जी,
तो प्रोबेबिलिटी डेंसिटी फंक्शन में मतलब एक हम जब एरिया फाइंड करते थे गॉसियन इंटीग्रल बनता था, जो गॉसियन कर्व पता नहीं मैंने कहीं पढ़ा था,
नहीं
तो
वो
उसके बारे में थोड़ा.
गॉसियन एक कंटिन्यूअस है, वो आएगा, वो हम पढ़ेंगे कोर्स के अंदर. गॉसियन रैंडम वेरिएबल जो है वो हमारे पास आएगा, गॉसियन या नॉर्मल रैंडम वेरिएबल उसको कहते हैं, तो वो हमारे पास आएगा. दैट इज एन एग्जांपल ऑफ अ रैंडम वेरिएबल व्हिच इज अ कंटीन्यूअस रैंडम वेरिएबल. जिस तरह हमने डिस्क्रीट रैंडम वेरिएबल बहुत सारे पढ़े थे, उनकी एग्जांपल्स पढ़ी, बाइनोमियल, पोसॉन, ज्योमेट्रिक, इसी तरह कंटीन्यूअस रैंडम वेरिएबल की बहुत सारी एग्जांपल्स हैं जिसमें एक्सपोनेंशियल है, गॉसियन या नॉर्मल है, और गैमा रैंडम वेरिएबल. ये सारी जो हैं ये एग्जांपल्स हैं कंटीन्यूअस रैंडम वेरिएबल की. अभी तो हम कंटीन्यूअस रैंडम वेरिएबल की बिल्कुल बेसिक्स कवर कर रहे हैं. सो आई एम जस्ट ट्राइंग टू फिनिश दैट. हाँ, गॉसियन रैंडम वेरिएबल आएगा, उसकी फिक्र नहीं करें आप, ठीक है.
ओके ओके, थैंक यू.
सो लेट्स से कंप्यूटर क्रैश को हम मॉडल करते हैं. कंप्यूटर क्रैश. सो अमाउंट ऑफ टाइम अ कंप्यूटर वर्क्स बिफोर क्रैशिंग इज अ रैंडम वेरिएबल. ठीक है, कि एक कंप्यूटर आपने ऑन किया, उसके बाद वो कंप्यूटर जो है वो चलता रहा, एक टाइम पे आके उसने क्रैश कर गया. ठीक है, कितनी देर के बाद उसने क्रैश किया, वो टाइम जो है that is not a discrete time, that is a continuum of value, that is taking a continuum of values, it's a continuous random variable. Okay? So computer crash time is a random variable x, with PDF. आपको उसका PDF दिया हुआ है. With PDF f(x)(x) is equal to lambda e to the minus x over 100, x greater than equal to 0. Obviously crash time जो है वो 0 से छोटा तो नहीं हो सकता. crash time जो है वो जब आपने ऑन किया उसके बाद टाइम काउंट करना शुरू किया तो वो 0 से तो बड़ा ही होगा. Okay, so the way it looks like is हमें इस लैम्डा का नहीं पता कि ये लैम्डा क्या चीज है, लेकिन लैम्डा हम निकाल सकते हैं. we can find lambda. ठीक है, how do you find lambda? First we find lambda. How do we find lambda? We know that lambda e to the minus x over 100 dx integral from 0 to infinity, not from minus infinity to infinity, because 0 to infinity, because x is greater than 0, greater than or equal to 0. This should be equal to 1 because it is PDF. ये एक PDF है तो इंटीग्रेट होकर 1 ही होना चाहिए इसको. So इसको सॉल्व करेंगे. So इससे आपके पास आ जाएगा lambda is equal to 1 over 100. इसको सॉल्व कर सकते हैं इंटीग्रेशन एक्सपोनेंशियल की. नाउ वी आर आस्क्ड ये कंप्यूटर हमने ऑन किया और हमने कहा कि व्हाट इज द प्रोबेबिलिटी दैट x इज लेस देन 100, कि ये 100 घंटे से पहले फेल हो जाएगा. व्हाट इज द प्रोबेबिलिटी योर कंप्यूटर विल फेल बिटवीन 0 and 100, विच मीन्स कि 100 से पहले फेल हो जाएगा. लाइफ टाइम जो है उसका कंप्यूटर का क्रैश टाइम is less than 100. What is that probability? In order to answer that probability, so this is going to be 0 से 100. अगर इसका ग्राफ हम ड्रॉ करना चाहें इसका ग्राफ भी प्लॉट कर सकते हैं। अब हमें लैम्डा भी पता चल गया तो हमें ये पता चलेगा कि इसका ग्राफ जो है इट विल लुक लाइक दिस। ये 0 से पहले 0 है, फिर उसके बाद एक ये जंप है, फिर उसके बाद ये इस तरह का ग्राफ है और जो इन्फिनिटी तक जा रहा है। सो दिस इज एक्स एंड this is the graph of the PDF. This is your PDF. Your PDF. fxx. Okay. So 0 से 100, यहाँ पे कहीं पे 100 आएगा. 0 से 100 is this area under the curve. This area under the curve. 0 से 100 fxx dx, which is 1 over 100 lambda e to the minus x over 100 dx. Okay. This turns out to be 0.632. This is the probability that this guy will fail within the first 100 hours. Within the first 100 hours. Okay. एक और example करते हैं. One more example. Okay. So lifetime of a radio component. Radio components radars में इस्तेमाल होते हैं और बहुत सारी जगहों पे electronics में इस्तेमाल होते हैं. ठीक है. Lifetime of a radio component. लाइफ टाइम ऑफ अ रेडियो कंपोनेंट. एक रेडियो कंपोनेंट आपने लिया, उसकी कोई लाइफ टाइम है. दूसरा लिया, उसकी भी कोई लाइफ टाइम है. इंडिपेंडेंट उसकी लाइफ टाइम है. उसका प्रोबेबिलिटी डेंसिटी फंक्शन उसने हमें दिया हुआ है एफ एक्स एक्स. एक्स इज द रैंडम वेरिएबल विच इज द लाइफ टाइम ऑफ ए रेडियो कंपोनेंट, हैज ए प्रोबेबिलिटी डेंसिटी फंक्शन एफ एक्स एक्स विच इज गिवन बाय 0 if x is less than equal to 100, and it's given by 100 over x square when x is greater than 100. What that means is कि the chances that ये 0 का मतलब ये है कि ये x less than 100 के ऊपर जो है वो इसकी लाइफ जो है वो there is no area there, so the probability that you will have something less than 100 is going to be 0. यानी ये 100 साल से पहले तो फेल होने वाला नहीं है, या 100 मिनट से पहले या 100 सेकंड से पहले. Okay. So now you are given that you use 5 such components in a project. कोई प्रोजेक्ट किया आपने, वहां पे 5 components को इस्तेमाल कर लिया. Okay. The probability you will need to replace exactly 2 such components in the first 150 hours. तो 100 घंटे तक तो कुछ होता ही नहीं है उस कंपोनेंट को. 100 के बाद जो है वो चांस होते हैं कि वो फेल हो जाएगा. सो हमसे सवाल ये पूछ रहे हैं कि व्हाट इज द प्रोबेबिलिटी इन द फर्स्ट 150 आवर्स ये कंपोनेंट जो है वो फेल होगा, और आपको 2 कंपोनेंट्स रिप्लेस करने पड़ेंगे. एग्जैक्टली 2 सच कंपोनेंट्स रिप्लेस करने पड़ेंगे. ठीक है. आपने कितने कंपोनेंट्स इस्तेमाल किए? 5 सच कंपोनेंट्स आर यूज्ड. ठीक है. तो इसको आंसर करते हैं. फॉर ईच कंपोनेंट probability of EI. So for each component I, where I is equal to 1 2 3 4 5, 5 कंपोनेंट इस्तेमाल किए हैं. हर कंपोनेंट के लिए probability EI, okay, and this event EI is that ith component fails within 150 hours. 150 के अंदर ही फेल हो जाता है. Probability EI is equal to integral minus infinity to 150, but it's 0 between less than 100, it's 0. So ये 100 से 150 तक इंटीग्रेट करेंगे. 100 over x squared dx, okay, which is equal to 1 over 3. This is the probability that a component will fail. एक कंपोनेंट फेल हो जाएगा, एक कंपोनेंट फेल होगा. अब आपने 5 ऐसे कंपोनेंट यूज किए हैं, and they are working independently. तो सवाल ये है कि आपने 5 ऐसे कंपोनेंट यूज किए हैं, क्या चांस है कि उसमें से एग्जैक्टली 2 फेल हो जाएंगे. सो Musab says के in the chat window, Musab says के you can use binomial. Obviously you will use the binomial. हम binomial यूज करेंगे. क्यों? Think about it. ये प्रॉब्लम उसी तरह की बन रही है कि एक कंपोनेंट की आपने प्रोबेबिलिटी फेल होने की निकाल ली है, विच इज द प्रोबेबिलिटी ऑफ सक्सेस, एंड सक्सेस मींस कि कंपोनेंट फेल हो जाएगा. दैट इज योर सक्सेस. आपने 5 ट्रायल्स किए हैं, 5 कंपोनेंट लगाए हैं. व्हाट इज द प्रोबेबिलिटी? एग्जैक्टली 2 ऑफ दोस फेल. What is the probability? Exactly 2 of those fail. This is exactly what is answered by binomial. Exactly what is answered by binomial. So, so failure of the component is our success, and we need exactly 2 out of 5 successes, and this would be 5 choose 2, 1 over 3 power 2, 1 minus 1 over 3 power 5 minus 2, which is turns out to be 0.3292. वेरी सिंपल. तो जो प्रोबेबिलिटी आपने कैलकुलेट की, प्रोबेबिलिटी कैलकुलेट करने के लिए आपने कंटिन्यूअस रैंडम वेरिएबल का डेंसिटी फंक्शन इस्तेमाल किया और उसके बाद सीधा बाइनोमियल लग गया. ठीक है. नाउ some ways of finding CDF from PDF and vice versa. Okay. Relationship between CDF and PDF, ये हमने पहले भी बताई. राइट हियर कि CDF आपको क्या बताता है? CDF is the probability that x takes a value less than or equal to a, which is the same as the probability x is less than a. ठीक है. इसमें कंटिन्यूअस के केस में लेस देन और लेस देन इक्वल टू जो है उसका कोई मतलब नहीं होता, एक ही बात है. Why? Because the probability x is equal to a is always 0. So the probability x takes a value less than a, is given by this area under the curve. ये जो सारा एरिया हमने पहले रेड किया हुआ. ठीक है. सो पीडीएफ में हमने देखा कि अगर आप इंटीग्रेट कर दें अप टू ए इंटीग्रेट कर दें, यू विल गेट द सीडीएफ. ठीक है. If you can integrate the PDF to get the CDF, then you can get the PDF from the CDF by differentiating. Okay. So let me define the CDF fxa, ये हमें पता है पहले, is the probability that x takes a value less than equal to a, okay, which is the same as the probability x is less than a, okay, which is the same as the probability that x belongs to a region minus infinity से a तक के region को वो belong करता है, which is equal to the probability minus infinity to a integral fxx dx. So ये this fxx is your PDF. So this is your fx of a. Okay. Now this is the relationship to get the CDF from PDF. CDF from PDF. ठीक है. इसको डिफरेंशिएट करते हैं with respect to a. डिफरेंशिएट करते हैं. So d by dA of fxa is equal to d by dA of, देखें ये ऊपर डेफिनेट इंटेग्रल है, और ये जो डेफिनेट इंटेग्रल जो है, ये जब आप पहले इंडेफिनेट इंटेग्रल कैलकुलेट करेंगे और उसके बाद उसमें वैल्यू a डाल देंगे और फिर माइनस इन्फिनिटी डाल देंगे. ठीक है. सो दिस वुड बी द d by dA of g of a minus g of minus infinity, where g is the indefinite integral. ऐसे ही होता है ना, डेफिनेट इंटेग्रल ऐसे ही फाइंड आउट करते हैं कि पहले इनडेफिनेट इंटेग्रल फाइंड आउट करते हैं और उसके बाद 2 वैल्यूज पुट कर देते हैं. सो ये आपने पहले इंडेफिनेट इंटेग्रल फाइंड आउट किया और इंडेफिनेट इंटेग्रल ऑफ fxx Okay. Okay. Thus, the derivative with respect to a of fxa is going to be equal to, देखें अब यहाँ पे क्या है कि this is the derivative with respect to a of a constant. ये constant जो है आपका, ये second term जो है ये constant है, ये second term जो है ये constant है, इस constant का derivative क्या होगा with respect to anything? वो zero होता है. और what would be the derivative of g of a with respect to a? That would simply be fx of x. Why? Because g of a is actually the g of x is the indefinite integral of fxx. Okay. So कुछ properties यहाँ पे, some properties, ये कुछ एग्जांपल्स आएंगे जहाँ पे CDF से PDF निकालना है, PDF से CDF निकालना है, so it will become even more clear. So properties of PDF and CDF for continuous random variable, ये एक recap हो रहा है आपका, ये recap हो रहा है. सबसे पहले probability that x takes a value a is always zero. X taking a specific value is always zero. दूसरी चीज, the probability x takes a value less than equal to a, this is the same as the probability x takes a value less than a. Why? ऊपर वाले की वजह से. x taking a value a is zero, the probability of that is zero, तो इसका मतलब है कि ये दोनों बराबर होंगे. तीसरी चीज fxx, the PDF is always non-negative, greater than or equal to zero. Non-negative, नेगेटिव नहीं हो सकता. अगर नेगेटिव हो गया तो कुछ प्रोबेबिलिटीज नेगेटिव में चली जाएंगी. ऑब्वियसली नॉट अ गुड आइडिया टू हैव दैट. उसके बाद इंटीग्रल फ्रॉम माइनस इंफिनिटी टू प्लस इंफिनिटी fxx dx, this would be equal to 1. Okay? This is PDF sums to 1. PDF sums to 1. fxx, the CDF, is monotonically non-decreasing. Why it is non-decreasing? This is non-decreasing because probability x is less than or equal to something. That's the CDF. आपका CDF होता है probability x less than or equal to something. Okay? So हम ये कह रहे हैं कि अगर ये आपका PDF है, and this is x, okay? Then the probability x takes a value less than or equal to a is given by this red area. Okay, and then the probability x takes a value less than or equal to b is given by this area. Yes, sara ka sara. Okay? See, the green area can never be smaller than red area. Green area includes the red area. So fxb is always greater than or equal to fx of a. Okay? So the green area is always going to be greater than or equal to red area. ठीक है. So इसलिए जब A से B पे जाते हैं तो आपका CDF जो है उसका अगर आर्गुमेंट इंक्रीज करते हैं तो it can never decrease. Okay? So non-decreasing, monotonically non-decreasing. Now the CDF fx of minus infinity is zero. Okay? माइनस इन्फिनिटी से पीछे तो कोई एरिया ही नहीं है. ठीक है. Similarly, fx of plus infinity is 1. प्लस इन्फिनिटी से पीछे सारा का सारा एरिया कवर्ड है. Then fxx is continuous, no jumps, as we saw in the case of discrete random variable, unlike the case of discrete random variable, Okay. And then you can obtain PDF from CDF and vice versa. Okay. How? You can obtain the CDF from PDF by integrating from minus infinity to x fx t dt. Okay. या अगर इसको आपको ऐसे पसंद नहीं है, इसको ऐसे भी लिख सकते हैं, fx of a would be equal to minus infinity to a fx of t dt, या fx of x dx लिखना चाहें, t लिखना चाहें, it doesn't matter. It's a variable of integration. It will go away anyways in the case of definite integrals. So this is how you obtain CDF from PDF. And how do you obtain the PDF from CDF? Fx of x would be equal to d by dx of capital Fx of x. This is just a very quick summary of the properties of the PDF and CDF for the continuous random variable. Okay. Now, just like we calculated the expected value and variance for the discrete random variables, similarly, we can compute the expected value and variance of the continuous random variables. So remember, recall that for discrete random variables, expected value of x, discrete random variable x, was equal to the summation upon x, the value that it is taking, multiplied by the corresponding probability, which is equal to x, the probability x takes a value x. This was for the case of discrete random variable. Now, for the continuous random variable, this probability is always going to be 0. ये तो हमेशा 0 होगी. हाँ? For continuous random variables, probability x taking a specific value will always be 0. ये तो 0 होगी, तो फिर ये कैसे कैलकुलेट करेंगे? वेल, ऐसे नहीं कैलकुलेट करेंगे, फिर ऐसे कैलकुलेट करेंगे जैसे हमने प्रोबेबिलिटी डिफाइन की थी. इसके केस में हमने प्रोबेबिलिटी डिफाइन की थी. हमने कैसे डिफाइन की थी? So we try to find the probability that x lies in a small region near x. That x, capital X, your random variable, lies in a small region. ये मैं इसको रेड से करता हूँ. So think of it as a small region. यहाँ जरा बड़ा शो किया है दिखाने के लिए. X and x plus dx, such that this guy here is dx, okay, and this is your probability density function, PDF. Okay. So let's find the probability that x random variable is in a region x plus dx. ये एक छोटे से रीजन के अंदर लाई करता है, which is equal to this area under the curve. So this is equal to integral x से x plus dx, ये हमने पहले भी किया, fx of t dt. This is t. This is equal to fx of small x into dx. So this is the probability that x in a region, capital X, the random variable x, is in a region very near to x, in a small region near x, Okay. So equivalently, we define the expected value of x as expected value of x is equal to, just like in the case of a discrete random variable, this was equal to the summation of x multiplied by the corresponding probability. So here it is, instead of summation, it is the integration of x multiplied by the corresponding probability, which is fxx dx, and going from minus infinity to plus infinity. ये देखें, ये बिल्कुल एक ही जैसी चीज है. This guy here, जिसको भी मैंने ये green color कर दिया, and this guy here, जिसको फिर मैंने green color कर दिया, for the case of discrete. So not too different, you know. Here, this guy here is the probability. तो यहाँ पे आपने probability के साथ corresponding value को multiply किया और sum up कर दिया. यहाँ पे summation बस हमने ऐसी की है कि जो infinite type की summation. ठीक है? Now we can also define the expected value of a function of the random variable, of a function of a continuous random variable. This would similarly be equal to, जिस तरह discrete case में था कि वहां पर g of x को साथ corresponding probability से multiply कर देते थे, यहाँ पे corresponding probability है fxx dx. This is the probability. This is the probability. ठीक है? Example. So we get an example. So let's say you have a random variable x with probability density function fxx. So you have a question, please go ahead and ask. What's up?
Yes, sir. Sir, we are considering the limit from minus infinity to infinity. तो इस केस में हमारे पास will consider intervals when we are computing expectation of some random variable x.
हाँ, इंटरवल्स जो है हम कंसीडर करेंगे, लेकिन चूंकि हम इंटीग्रेशन कर रहे हैं, तो इंटीग्रेशन जो है वो कंटिन्यूअस ग्राफ आपके पास है, तो यू कैन हैव द इंटीग्रल डिफाइंड फॉर अ कंटिन्यूअस ग्राफ. जिस तरह समेशन जो करते हैं वो डिस्क्रीट वैल्यूज की करती हैं. जब आपके पास कंटिन्यूअस वैल्यू हो जाए तो आप उसकी समेशन कैसे करते हैं? उसकी समेशन जो है इंटीग्रल लेके करते हैं. तो अभी हमारे पास एग्जांपल आएगी. दो एग्जांपल्स मुझे करने दें, फिर ये आपका सवाल जवाब देंगे.
Okay, thank you, sir.
So let's say we have a function fx is equal to x and between 0 and 1 and otherwise. इस पीडीएफ को अगर मुझे ड्रॉ करने को कोई कहे तो ऐसे ड्रॉ कर लेंगे. ठीक है, ये इस तरह से ड्रॉ होगा. You have 0 and 1 here. Now notice that the area under the curve here is 1. So this is a PDF. Why? Because this is non-negative. Non-negative भी है, area under the curve जो है वो भी 1 हो जाता है. ठीक है, और ये रियल लाइन के ऊपर भी. So this is the probability density function. This is your probability density function. So I am interested in finding the expected value of x and expected value of some function of x. Some function जो भी हमसे पूछा जाए. So what would be the expected value of x? This would be equal to, अब देखें यहाँ पे आप जो है ना, आपको segments consider करने हैं, लेकिन integral automatically gives you that segmentation, and that segmentation is given by going from minus infinity to plus infinity fxx dx multiplied by small x. Okay, so this would be equal to, now fxx is equal to 0. अब ये segments में है, ये 0 है, यहाँ पे 0 है fx है, यहाँ पे भी 0 है. So the only place it is non-zero is between 0 and 1, and here the value of fxx is 1 dx. Everyone is okay with that? Yeah. So इसको सॉल्व करेंगे तो आपके पास आंसर क्या आ जाएगा? 1/2. वैसे भी हमें ये लग रहा है कि ये एक रैंडम वेरिएबल है, ये यूनिफॉर्म सी डिस्ट्रीब्यूशन है बिटवीन 0 and 1. इसकी एवरेज वैल्यू जो है वो 1/2 ही आनी चाहिए. एक्सपेक्टेड वैल्यू वो 1/2 है, और वही हमारे पास आ गया. एक और क्वेश्चन जो इसी रैंडम वेरिएबल के बारे में, व्हाट इज द एक्सपेक्टेड वैल्यू ऑफ e to the power x? Expected value of e to the power x. realize that e to the power capital X is also a random variable. Okay, it's a function of a random variable, so it is a random variable. So this will be also equal to minus infinity to plus infinity, minus infinity to plus infinity, e to the power small x into fxx dx. Okay. And again, this would be equal to this fxx is non-zero only between 0 and 1. So this would be into 1 dx, which is equal to e minus 1. E minus 1. ये आंसर आ जाएगा. Now, for a linear function, y is equal to ax plus b of a continuous random variable x, okay, we have expected value of y is equal to expected value of a times x plus b. A and b are constants. This would be equal to a times expected value of x plus b, same as in discrete case, जो discrete के केस में थी बिल्कुल उसी तरह से यहाँ पे भी. सो ये एक्सपेक्टेड वैल्यू हमने डिफाइन कर दी, बिल्कुल उसी तरह से वेरिएंस भी डिफाइन कर सकते हैं. वेरिएंस ऑफ कंटिन्यूअस रैंडम वेरिएबल, कैसे डिफाइन करेंगे? बिल्कुल उसी तरह से जैसे डिस्क्रीट के केस में थी. वेरिएंस ऑफ x would be equal to the expected value of how much the random variable drifts away from the expected value. ये देखें, this is x minus ex is how much your random variable goes away from the expected value. उसका स्क्वायर लिया तो this is a random variable, इसका स्क्वायर भी random variable है, उसकी expected value आपने ली है. This would be, इसको हम सॉल्व कर सकते हैं बिल्कुल उसी तरह जैसे डिस्क्रीट के केस में किया था. एक्सपेक्टेड वैल्यू ऑफ एक्स स्क्वायर माइनस एक्सपेक्टेड वैल्यू ऑफ एक्स होल स्क्वायर. Once again, for a linear function, y is equal to ax plus b. Variance of y is equal to a square times variance of x. That's it. b I नहीं रहा. There is no b here. Same as in discrete case. बिल्कुल discrete के केस में भी ऐसे हमने किया. And why is that? Once again, इसकी रीजन ये है कि ऐसा है कि अगर मैं क्लास में सारे स्टूडेंट्स के मार्क्स में कुछ कांस्टेंट ऐड कर देता हूँ, उससे वेरिएंस पे कोई फर्क नहीं पड़ता, ठीक है. लेकिन किसी एक नंबर से सबके स्कोर्स को मल्टीप्लाई कर देता हूँ, डबल कर देता हूँ, तो उसकी जो वेरिएंस होगी वो 4 टाइम्स ज्यादा, वेरिएंस जो है वो 4 टाइम्स ज्यादा हो जाएगी. ओके, सो example is in order. So example would be, you are given a random variable with probability density function fx is equal to 2x between 0 and 1, okay, and 0 otherwise. इसको ड्रॉ करते हैं, पहले देखते हैं कैसा लगता है, ठीक है. So this random variable is taking a value 0 otherwise except for between 0 and 1. 0 and 1 के बीच में ये 2x आपकी वैल्यू दे रहा है, और ये this would be something like this. ठीक है. Now since it is taking the value 2x, so at 1 this value here it will be 2. Okay? Now let's see if the area under the curve is equal to 1. Area under the curve is equal to 1. This is a triangle, so this would be half into base into height, which is 1 by 2 into 1, which is equal to 1. So this is a PDF. This is non-negative, this is non-negative, and this is a PDF here. So ये हमें PDF उसने दिया हुआ है. Now this guy is asking us the question, okay, find the expected value of x. Expected value of x. So expected value of x would be equal to integral from 0 to 1 x into 2x dx. This is the fx dx in the interval 0 to 1. In the interval 0 to 1. Okay. This will turn out to be 2x cubed over 3 from 0 to 1. So this will be equal to 2 over 3. 2 over 3. Second part, variance of x. Variance मालूम करने के लिए हम क्या करेंगे? So one possibility is कि you use this formula. You can use this formula. There is no question about it, and it will give you the accurate answer. You can also use this formula. This is, in this case, slightly easier to use. So variance of x in this case would be equal to, we first find e to the x square, which is equal to expected value of x square. What would that be? That would be 0 to 1 x square into 2x dx. This is again your fx dx, and this is the function x square. So this would turn out to be 2 into x4 over 4, 0 to 1. So this would be 1 over 2. So the variance of x would be equal to expected value of x square minus expected value of x whole square, which would be expected value of x square was 1 over 2 minus expected value of x whole square would be 4 over 9. So this turns out to be 1 over 18. And convince yourself that the variance cannot be negative. Why it cannot be negative? Why? Because it's the expected value of a random variable which is always positive. ये square है. Square हुआ है वो कभी negative नहीं होगा. So this is the expected value of a random variable which is always positive. So this number has to be positive. The variance will always be positive. Cannot be negative. Okay. Now, just like in the case of discrete random variable, we saw the examples of some famous random variables. We will do the same here. So examples of some important continuous random variables. Examples of some important continuous random variables. Now, so this random variable, first one that we are going to handle is called a uniform random variable. Uniform random variable. In fact, we've already seen that. ये जो random variable हमने यहाँ draw किया था, this is a uniform random variable, जिसका probability density function uniform रहता है over an interval of time. वो interval कुछ भी हो सकता है, but it has to be uniform over an interval of time. So I will generalize this definition. So uniform random variable, for uniform random variable, fxx is equal to some constant k or uniform between small a and small b over an interval of time and 0 otherwise. What that means is ये इस तरह का लगेगा कि between a and b, this guy is equal to k, and outside this interval, this is 0. Outside this interval, this is 0. ठीक है? So ये हमने क्या किया? ये हमने PDF draw कर दिया fx of x, and small x is here, and this number here is k. Can anyone guess k what would k be equal to if this is a PDF? If this is a PDF, कोई बता सकता है? So yeah, since the area has to be equal to 1, so since the length here is b minus a, so k has to be equal to 1 over b minus a. Thank you, Umar Mahmood, आपने जवाब दिया. So for this to be a PDF, for this to be a PDF, k should be equal to 1 over b minus a. 1 over b minus a. ठीक. और वो कैसे निकला है हमारे पास? हमने इंटीग्रेट किया पीडीएफ को माइनस इन्फिनिटी से प्लस इन्फिनिटी तक, उसको 1 के इक्वल सेट किया, वहां से किया, हमारे पास निकल आएगा. नाउ हाउ डज द सीडीएफ ऑफ दिस गाय लुक लाइक? हम जरा सीडीएफ ड्रॉ करने की कोशिश करते हैं. सो सीडीएफ ड्रॉ करते हैं, इसी एक्सिस के ऊपर ड्रॉ करते हैं. सो सीडीएफ इज द प्रोबेबिलिटी, CDF is the probability your random variable takes a value less than or equal to something. So CDF की axis ये, what is the probability you take a value less than equal to a? What is the probability you will take a value less than equal to a? It's going to be zero. क्योंकि a से छोटी वैल्यू ले ही नहीं सकता रैंडम वेरिएबल. रैंडम वेरिएबल can only take value between a and b with some uniform probability distribution function. Okay? Now, as you increase, यहाँ से जैसे जैसे आगे होते जाते हैं, remember हमने कहा था कि CDF is the integral of the PDF. इसको अगर इंटीग्रेट करें PDF को अगर इंटीग्रेट करें, PDF को अगर इंटीग्रेट करें, then as you go further right, ये इंक्रीज होता जाता है, एरिया अंडर द कर्व इंक्रीज होता जा रहा है, और यू हिट हियर, ये हिट किया जहां, और उसके बाद एरिया कितना इंक्रीज हो रहा है? कोई एरिया इंक्रीज नहीं हो रहा है. सो दिस हैज टू बी 1 एंड दिस हैज टू बी a, दिस हैज टू बी b, दिस हैज टू बी 0, और ये आपके पास 1 तक पहुंच गया. दिस इज योर CDF, दिस इज योर CDF, your CDF, capital Fx of x. So what is the expected value of the random variable here? Expected value क्या है? So to find the expected value, you take minus infinity to plus infinity x fx x dx. So this would be equal to, देखें fx x dx जो है, this is non-zero only between a and b, so this would be between a and b, x into, what is the value of fx x between a and b? This is equal to 1 over b minus a. ये k है, equal to k है, into dx. And solve this, you will get a plus b over 2, which is what we expected. कि ये एक random variable है, taking value between a and b with uniform probability. So उसकी average value जो है वो a और b के दरमियान में होनी चाहिए, और ये ऐसे ही है, a और b के दरमियान में. To find the variance, let's find the expected value of x square. Expected value of x square would be a to b x square 1 over b minus a dx. This would be equal to a square plus ab plus b square over 3. ये solve कर सकते हैं आप करते हैं. So the variance of x is going to be expected value of x square minus expected value of x whole square. This will turn out to be, and you can solve this, b minus a whole square over 12. Very important formula that we often use. Okay? जिसको हम easily derive भी कर सकते हैं. Of course, हमने ये derive कर लिया है उसको. What is the CDF? CDF is probability x is less than equal to small x. This would be equal to, it's basically this function. This function की expression. So this would be a straight line की equation है. So straight line की जो equation है वो x minus a over b minus a. This is the slope and intercept. ये दोनों चीजें मैंने इसमें डाल दी हैं. For a is less than equal to x is less than equal to b. So x between a and b, x between a and b. This would be the formula for the PDF, which is simply the expression for this straight line. Expression for this straight line. So special case uniform random variable ka special case of uniform random variable, a is equal to 0, b is equal to 1, which means कि ये इस तरह का फंक्शन बनेगा आप लोगों के पास. Okay, 0 से 1 तक और ये 1 होगा. K will be 1. So this would be the special case, okay, for which you can find that we already found the expected value. We already found expected value of x and variance of x for this special case. Okay. So so we have a few examples that we will cover in the next lecture. I think we are this is about time, 1 hour 17 minutes. If there are any questions, Musab, Umar, Zishan, एक तो आप तीनों का शुक्रिया कि आपने टाइम निकाला and you are here and I don't have to speak to the balls. So if you have any question, I will be happy to answer now. Otherwise, I will just stop the session. कोई question है आप लोगों का? So Musab का कोई question नहीं है. Umar, Zishan, do you have a question? No question. And Umar का भी कोई question नहीं है. This is great. Okay, so I will see you. These lectures obviously are for, this one is for Saturday, and we will have a live session next Wednesday, inshallah. Okay, Khuda Hafiz.